For most of its observed trajectory, 3I Atlas appeared indistinguishable from what astronomers would expect of a typical interstellar comet. Early measurements showed a diffuse coma, modest outgassing, and brightness changes that broadly tracked its distance from the Sun, all well within established physical models. There were no intense signals, no sudden flares, and no behaviors that immediately challenged conventional explanations. Because of this, 3I Atlas was initially categorized as a routine interstellar visitor rather than a disruptive anomaly. That perception held until it passed through a critical observational geometry. When viewing angles shifted and the accumulated data began to reveal subtle inconsistencies, details that no longer aligned perfectly with the assumptions used to describe an ordinary comet. What was it about these seemingly familiar data sets that ultimately forced scientists to pause and re-examine what they thought they were seeing? A deeper analysis showed that the emission behavior of 3I Atlas did not evolve in simple lockstep with its changing distance from the Sun, suggesting that its activity was governed by internal processes rather than solar heating alone. Certain optical and X-ray emission components appeared with a measurable delay relative to peak activity, a pattern that differs from most well-studied solar system comets and points toward a more complex interaction between released gases and the surrounding plasma environment. At the same time, the coma's structure changed more rapidly than standard sublimation models predict, implying uneven material distribution across the surface or within the nucleus itself. Estimates of its rotational state hinted at instability, consistent with a body that is structurally heterogeneous rather than uniform. None of these observations indicate artificial origin or exotic technology. Yet taken together, they are sufficient to rule out several simplified comet models that work well for native solar system objects. In that sense, 3I Atlas stands as a clear illustration of how science progresses. A phenomenon can appear entirely normal until careful. Sustained observation reveals that normal is no longer an adequate explanation.